Here we have an isosceles triangle ABC with two equal sides of the measure 6 centimeters inscribed inside a circle of radius 9 centimeters. What we need to find is the area of this given triangle. Now, as you know, an isosceles triangle comes with a bucket load of properties. What we are going to use is the properties of a kite. What is a kite? It is a quadrilateral with two pairs of equal adjacent sides. That means these two sides will be equal to one another and these two sides will be equal to one another. Can we get such a situation here? What if we join BO and OC? Both of them will be the radii, which means you have a 9 centimeter here and a 9 centimeter here. We have got a kite here. And now what is the property that we are going to use? We know that the diagonals of a kite are perpendicular to one another. Not only that, the longer diagonal bisects the shorter diagonal. Now I know what is the first question that will come to your mind. How do I know which one is the longer diagonal and which one is the shorter diagonal? The longer diagonal is the one which connects the vertices joining equal sides. This vertex here which joins the 6 centimeter and this vertex here. So this diagonal AO is the longer diagonal or the main diagonal, and this one is the shorter diagonal or the cross diagonal. And what does the property say? These two diagonals are perpendicular to each other. Not only that, the long one cuts the shorter one into two equal parts. Now, suppose the place where it cuts, I will name this F. So, I will name this part as say X. Let this much be X and this much FO would be how much? The whole of OA is the radius, which is 9 centimeters. If this is X, then FO will be what? It will be 9 minus X. So now what do we have? Two beautiful right triangles. One with 6 centimeter as its hypotenuse and the other one with 9 centimeters as its hypotenuse. Why is that? Because the side opposite to the right angle, opposite to the 90 degrees will be the hypotenuse. Not only that, there is another thing if you notice. Both of these right triangles, which I name 1 and 2, both of these right triangles has BF as one of its legs. The leg of a right triangle is the side which is not the hypotenuse. One of the smaller sides is what we call a leg, and these two triangles have BF as one of its legs. So go to the first triangle. What is BF square? Apply the Pythagoras theorem. What is BF square? It is 6 square minus x square. Now come to the second circle. Again, it is the same quantity. It is the same BF that you see here. But this time, what is the hypotenuse? The hypotenuse has changed. It is now 9 centimeters. And what is the other leg? What is the other shorter side? It is this small 9 minus x that you see here. So 9 square minus 9 minus x square here. What we do is apply the a minus b the whole square formula, which is a square minus 2ab plus b square. So you get two such equations, both for BF. So we have two different equations, both giving two different values for the same quantity BF. So let us equate both of them. 36 minus x square is equal to 18x minus x square. So what do you see? X is equal to 2 centimeters. So this much here, what is that actually? That is the altitude. If you see that, See here, it is actually the altitude of this triangle. So there I have removed all the unnecessary details. What we just now did was find the altitude, the measure of the altitude of the triangle ABC. Now using this in this equation, any of these two equations you can choose. Now here when we substitute the value of x is equal to 2, what do we get? We get BF is 4 root 2, but BF is not what we need. The base is the whole of BC, which is what? 2 times of BF. So what is your area? Your area is half into base into altitude. Now what do you know the altitude is? We found that it is 2 centimeters. What do we know about the base? Just this much is 4 root 2. So double of it will be what? 8 root 2. So there your answer is what? 8 root 2 centimeters square is the area of this isosceles triangle. So that is all for today. You take care. Assalamu alaikum.